Welcome to Physics for Engineers, and today's lesson, we're going to discuss about fluids. So our learning objectives in this lesson is to calculate the density of a substance, to determine the pressure relative to depth, and applying the Pascal's law, to calculate the buoyant force that a fluid exerts on a body immersed in it, to familiarize with Bernoulli's equation and equation of continuity, and lastly, to understand viscosity of fluid. Our topic outline, we will start discussing with fluid statics, covering density, pressure in Pascal's law, buoyancy, and in fluid dynamics, we will cover the fluid flow and viscosity. Density. So before we proceed to discussing density, we must define first what is fluid. So fluid is any substance that can flow. We use the term for both liquids and gases. We usually think of a gas as easily compressed and a liquid as nearly incompressible, although there are exceptional cases. So we begin our study with fluid statics, the study of fluids at rest in equilibrium situations. Like other equilibrium situations, it is based on Newton's first and third laws. We've explored the key concepts of density, pressure, and buoyancy. An important property of any materials is the density. It is defined as the mass per unit volume. A homogeneous material such as an ice or iron has the same density throughout. Two objects made of the same material have the same density, even though they may have different masses and different volumes. That's because the ratio of mass to volume is the same for both objects. We use the symbol ρ for density. If a mass m of homogeneous material has volume V, then the density is equal to mass divided by its volume. The standard unit for density is kilogram per cubic meter. In CGS, we use gram per cubic centimeter. Another property of material that is important to be um, discussed is about the specific gravity. It is the ratio of its density to the density of water at 4.0 degrees Celsius or 1,000 kilogram per cubic meter. Another term that's used for specific gravity is relative density because we use the density of substance um, relatively to our reference substance, which is water. The density of water is equal to 1,000 kilogram per cubic meter or 1 gram per cubic centimeter. In terms of gases, we may also use or we may also get the specific gravity for gas by getting the density of the gas over the density of air. So our reference substance is air, and the substance of air and the density of air rather is equal to 1.204 kilogram per cubic meter. Next property is a specific weight. It is the weight per unit volume. So in our case, our symbol for Specific weight is this one. Typically, specific weight is equal to the weight of a substance divided by volume. So instead of using the mass of the substance, we use the weight. That's why it's called specific weight, dividing by its volume. So we know that weight is equal to mass times the gravitational acceleration. And knowing that mass over volume is equal to density, or our specific weight is equal to density times the gravitational acceleration. In this table, we can see the densities of some common substances. Note the wide range of magnitudes. The densest material found on Earth is the metal osmium, but its density pales by comparison to the densities of exotic astronomical objects, such as white dwarf stars and neutron stars. So let's have our example problem. Find the mass and weight of the air at 20 degrees Celsius in a living room with a 4.0 meter by 5.0 meter floor and a ceiling 3.0 meter high, and the mass and weight of an equal volume of water. So in this problem, we are asked to find the mass of air and its weight, also the mass of water and its weight. So let's start off with finding the mass of air. So using the formula that density is equal to mass divided by volume, we can solve for mass by getting the product of density and volume. So the density of air is equal to 1.2 kilogram per cubic meter times 4 times 4 times 3, which is the volume of the room, which is equal to 60 cubic meter. Therefore, the mass of air is equal to 72 kilogram. Now, to get the weight of the air, we're just going to multiply the mass of the air with the gravitational acceleration. Therefore, 72 kilograms times 9.81 meter per second squared is equal to 700. And kilogram times meter over second squared is equal to Newton. Now for the second part, getting the mass of the water. With the same procedure, we just multiply the density of water and volume. So the density of water is equal to 1000 kilogram over cubic meter times the volume of the room, which is 60 cubic meter. Therefore, the mass of the water is equal to 6,000 kilogram. And finally, for the weight of the water, Let's multiply the mass of the water and gravitational acceleration. Therefore, we have 6,000 kilogram times 9.81 meter per second squared. Therefore, the weight is equal to 59,000 Newton, approximately. So that's our procedure in solving density, mass, volume. Okay, so let's try and test your understanding by solving this problem.